Now that the hydration enthalpy concept is clear to you, just like your lattice enthalpy, let's discuss where this hydration enthalpy is used, or let's discuss what are the application of this hydration enthalpy. So the first application, now let's consider the size of hydrated ions. Now what do you mean by hydrated ions? That means when your ions, suppose you have sodium chloride. So sodium, as we have already discussed, when dissolved in water, sodium will be covered with H2O. Similarly, your chloride ions will be covered or will be gathered by H2O. So sodium will be attracted, or let's say sodium will be attracted by water from oxygen side, because oxygen is slightly negative, and similarly your chloride will be attracted from the positive side of water, that is nothing but your two hydrogens. So your water molecules, they gather around your sodium and chloride. So these are nothing but your hydrated ions, that your sodium which is gathered by or which is covered by your water molecule is one hydrated ion, and your chloride which is gathered or covered by your water molecule is your another hydrated ion. So smaller is the size of the gaseous ion, smaller is the size of gaseous ion. Here we are talking about cation and anion, not the solution ion. Here we are talking about your cation and anion, not about the solvent. So look here carefully. Smaller is the size of gaseous ion, higher will be the hydration. What do you mean by this? That let's consider of sodium and chloride itself. Sodium being the smaller in size and chloride will be higher in size. So let's discuss about size. When we say that the smaller is the size of gaseous ion, higher will be the hydration, and hence more will be the size of hydrated ions. What do you mean by that? When your gaseous ion, when you consider two positive ion, let's consider lithium and sodium. When you consider lithium and sodium, you know the sizes of sodium, the size of sodium ion which is in the gaseous state is greater than lithium. So the size of gaseous sodium ion is greater than the size of lithium. So the lithium being the smaller in the size in the gaseous ion or the gaseous atom will attract, will have more hydrated water molecules around it, just like this, because lithium is smaller in size. But when we consider sodium in gaseous state, sodium in gaseous state will have little bit less hydrated ions, because it is quite bigger in size as compared to the lithium in the gaseous state. So we can say that the smaller the size of gaseous ion, higher will be the hydration. Now you tell me in which case in the lithium and sodium which will have the higher hydration? Obviously the lithium being the smaller size. So now you tell me in which possible way, or in the lithium and sodium, which one will have higher hydration? Obviously lithium will be the highest hydration, because the size of lithium is smaller than the size of sodium, and that's what we have seen. Smaller is the size of gaseous ion, higher will be the hydration, hence more will be the size of hydrated ions. Now what do you mean by that? That your lithium will be covered or will be attached or will be gathered by water molecule more due to the less size of lithium ion, and hence the hydrated ion that you are getting will be having more size, because more number of H2O are around the lithium. But when you consider sodium, sodium being the bigger in size, there will be the less H2O around sodium. So the hydration size, hydration molecule, or we say hydrated ion size of sodium will be less as compared to the lithium. I hope this is clear to you. Now let's look at the next.